Assalamualaikum and hi everyone. We are now in lecture 6, Transaction Management Part 1. At the end of this lesson, you should be able to explain transaction support, properties of transaction and the database architecture. Transaction is an action or series of actions carried out by user or application which reads or updates contents of database. Each operation on database can be considered as transactions. During transactions, database is transformed from consistent state to another state, although the consistency might be violated. This is an example of transaction, or what we can say as transaction schedule. You have the operation of read or write to the database. Transactions can have only two outcomes. It's either success or failure. Success means transactions commits and database reach a new consistent state, while failure means transaction aborts or rollback and database must be restored to consistent state before it started. This is a state transition diagram for a transaction. When you start the transaction, it is in the active stage. After reaching final stage of transaction, it can be in partially committed stage, which sometimes the transaction might violate certain database rules such as integrity constraint and it may fail. If it's failed, the transaction cannot be committed or the transaction is aborted while in the active state. But if it's successful, commit command is issued and data will be permanently stored in a database. There are four basic properties of transaction which is called as ACID. A is atomicity. It is all or nothing property. Means if your transaction has four processes, all four must be successful. If not, your transaction is entirely aborted. Second one is consistency. Before you start the transaction, database must be in a stable state. After you finish the transaction, database is transformed to another stable state. I is for isolation. The partial effects of incomplete transactions should not be visible to other transactions. D is durability. Once data is committed in a database, it will not lose even if you have a system failure. Another property that we can add is S, serializability. We will take a look at this later in the next section. Next is about DBMS transaction subsystem. The first subsystem is transaction manager. It will coordinate transaction on behalf of application program and communicates with scheduler. Scheduler is referred to as a lock manager if the concurrency protocol is locking based. Next is recovery manager. It is responsible for the efficient transfer of data between disk storage and main memory. The last one is buffer manager to ensure database is restored to the state it was in before the start of the transaction and therefore a consistent state. So I guess that's all for now. See you again in the next part. Thank you.